Hello and welcome to Clear Water Quality. In this video, I'm going to show you how to derive the next line on the precipitation diagram for manganese hydroxide. So in the previous three videos, we derived lines that show the equilibrium with three different aqueous species that are in equilibrium with the solid. And in this video, I'm going to show the last complex. Okay, so to start with, I'm going to use the fourth reaction list up here, which is the precipitation or solubility reaction for manganese hydroxide solid. And I'm going to add it to the reaction for the third complex, so the third reaction. So I have manganese hydroxide solid. It dissolves into its ions, manganese free ion plus 2 hydroxides, and the equilibrium constant is KSO. And then I'll add the third complexation reaction, which is manganese free ion plus 3 hydroxides, and they form manganese hydroxide complex. And this is described by beta 3 as the equilibrium constant. So I add those together. 2 of the hydroxides cancel out, both of the manganese ions, and I'm left with manganese hydroxide solid plus a single hydroxide forms manganese hydroxide complex. And the equilibrium constant is KSO times beta 3. Okay, so one thing I do need to use is based on the water equation, I know that Kw, 10 to the minus 14, is hydroxide times hydrogen. So I'm going to make a substitution where hydroxide is Kw over hydrogen. Okay, so I'm going to write out the mass action or equilibrium equation for this reaction. I have KSO times beta 3 is equal to manganese hydroxide complex over manganese hydroxide solid times hydroxide. Next, I'll make a substitution for the hydroxide, and the solid is 1, as is our convention in these systems. And I'll substitute with the hydroxide, Kw over H+. I'll take the log of both sides, so I have log KSO plus log beta 3 is equal to log manganese hydroxide complex plus log hydrogen minus log Kw. I can start making substitutions now. So beta 3, this is 7.8. KSO, so I have negative 12.8. The log of the manganese complex stays a variable, and pH is negative log H+, so this is going to be negative pH, and this will be plus 14. So then I'm left with an equation for a line. So I have log manganese hydroxide complex is equal to negative 19 plus pH. And that is the equation of a line that describes the equilibrium of the complex with manganese hydroxide solid. So I wrote in our software code in order to plot this. If you're plotting by hand, you can just solve for a couple pHs. You can solve for any pH, but I've got 8 and 10. And at those values, my complex is equal to negative 11. And at the pH of 10, it's equal to negative 9. So you can plot those on a hand-drawn plot and then draw the line for the manganese hydroxide complex. On my plot over here, the blue line represents the free complex or the free ion. The green line represents equilibrium with the first complex. And then the purple line represents equilibrium with the second complex. And the orange line represents equilibrium with the third complex. Make sure that right there on that one. And those are the equations of the lines or the lines on the precipitation diagram. In the next video, I'll go over how to interpret this.